Alright, in today's video what we're going to do is connect the LabQuest 3 to the GoDirect Pressure sensor and also the temperature probe, the GoDirect temperature pressure interface. So the first thing you do is you turn on your LabQuest 3. We're going to go ahead and run this one wirelessly. We're going to connect through the Bluetooth. There you go, LabQuest is starting. Please wait. This guy fire up. I am going to go ahead and run this plugged in. If I have it plugged into the AC, I'm able to do a setting in there where we'll actually have these set up for you so that when they're plugged into the AC, then the screen will stay bright. And that'll just save you some trouble with it going to sleep from time to time. So you turn on the LabQuest 3, step 1. Step 2, you turn on the gas pressure interface. Just one click, you'll see that start to flash red. And then you do your little temperature probe over here. One click. And I'm going to kind of twist it real quick. You'll see it also turn red. Now we're all connected, or we're all turned on. So now let's go to the connection part. So now we go back to do the connection. There is, so it looks like a kind of a speedometer up here and to the left. You have file, you have sensors, so push down sensors. We're going to do wireless device setup, and we're actually saying GoDirect. Maybe a little bit of counterintuitive. And when that happens, you'll see, at this point I see the GDX temperature, so I'm going to grab it, say OK, and it has a serial number. So that's now connected to the temperature probe. So that is connected here to the actual sensor itself, the temperature probe. But I didn't find my interface. I'm going to just take the box out of the stand, get it a little more proximal to the LabQuest. So we're still blinking. Now I'm going to try it again. There we go. Now we found it. Confirm that serial number. By the way, the serial number is right here by the barcode. Now we're connected. Now they're both in place and we're good to go. We're going to do this in time-based mode. So when you do time-based mode, that means that you're going to basically get temperature and pressure over, a length of time, but you're going to sample ever so often. So to me, if I set my units in seconds and I want to run for 3,600 seconds, that means I'm going to run it for an hour. Just that gives me plenty of time. I won't necessarily run it that long, but at least I don't have it set too short. But that way I can think about it this way and go, okay, I'm going to get 5 seconds per sample. So I know every 5 seconds I'm going to take a sample. And that works. Now I go back in here. And the way I'd like to track this is I'd like to use my table, and I'm going to, there was already a run in there, so I'm going to do another run once I push start, and I'm going to discard the other run. It's kind of fun, you can append to it or whatever. So now I'm running. So every 5 seconds it says, okay, the temperatures, and I've got it up to about 50, pressure's about 83.5. and I can make adjustments to this on my table, or if I want to run it in different units, I might stop my run, go out here, go back to my settings, I have the temperature and pressure here, so I can actually click the temperature, for example, change the units and say, okay, I'm going to run it Kelvin. Pressure, I'd rather run it in, for example, torr. And so now I'm going to be running in Kelvin and torr. Basically do the same thing. Time-based run. Everything's set up as I want. So okay, we're ready to go, and then I'm going to look at it on the table form. And at this point, I'm ready to start. Discard my old run. I'm not going to append it. So now I'm running Kelvin and torr. Those are the units I like. You can change all that in Excel. If you've already started in units you don't want, that's okay. You can fix it after the fact. Now I'm actually ready to start my experiment. I'm gathering data. Everything's in place. But I'm not measuring the vapor pressure. So we'll go over here and look at the experimental setup. At this point, the vapor pressure is just equilibrated with the room because this is open, right? So one of the things we have is we have a stopper. So we want it to be cooling because as it cools, it's going to just keep a tight seal on that. If I sealed this beforehand, I'd be pushing all that vapor pressure buildup against the instrument. So that's really hard on the instrument, and also would just blow the cork out. So the way we want to do that is we want to remove it from heat. It's going to start then to create vacuum inside the vial and seal it off. So this is why I have this particular stand set up the way I do, so that you can just simply lower the heat away without messing up any of the adjustments. Okay, so now the heat is out of the picture. So now it's going to start on its cooling process. And I can start measuring pressure. Nice snug lure lock fit on there. And then I'm going to make a note that my official vapor pressure startup was at about 115 seconds. And away we go. So my goal is I want to see 40 degrees, which is at 313 Kelvin, and the room temperature right now is 20.5 degrees Celsius, which would be 293.5 Kelvin. So I want to drop below 313, get quite a few degrees below there, and get as close as I can down to 293. But if I'm, if it starts the baseline at about, 300, something like that, then I'm okay. So at this point we passed we're getting into the 40 degrees Celsius mark. So right now we're at 40.8 degrees Celsius in essence, or 313.8 degrees Kelvin. So we want to pay attention to what the pressure is as we pass the 313.0 mark. So at 313.0 we got an average between 598.7 and it looks like the 598.5. So you can work that out. Now the objective is just to let it get down close to baseline, which is right around, in the room right now it's 293.5. 312, we want to get it down to 293. If you let it get right to room temperature, sometimes you have it so at such a baseline that it kind of distorts the curve data. So I think it's reasonable here to just run, you know, another 5 degrees or so and call it good. All right, we dropped another 5 degrees below 40 degrees Celsius, so we're now down to 308, and I think that's a good place to call the experiment. So I'm going to push stop. There we go. All right. Now what we want to do is we want to capture the data. So we're going to put the flash drive in labquest 3. Right. We hit File, Export. So it says it's going to a USB. It's untitled, so we'll change that up and we'll just call it water. Whatever you'd like to call it, give it a unique name so that make sure you put your initials on it or whatever, because a lot of students use these flash drives, so you want to be able to find your data later. Okay, export to text. Okay, and that should be done. So now we'll go from here to work that up on the computer. Pull the flash drive, take the flash drive over to my computer. At this point, while you're processing data, you might want to make sure your next experiment's up and running. So now what we're going to do is basically open up Excel, open up a blank workbook. I'm going to, I've taken the flash drive, I put the file, I like to put it on my hard drive. You'll want to put it somewhere in one of your folders. In other words, I don't want to just work off the hard drive, or off the flash drive. So I take it off the flash drive, put it on my computer. All right. So I like to open Excel. I've already put in the data from the flash drive, put it onto the hard drive. I'm now going to open my Excel file, and then I'm going to open it from within Excel. You can sometimes just click and open a file, but that doesn't always work so well when you have files that are in different formats. In this case, it's going to be in a text file, so that quite often is problematic. Here we go. It's all right to take my mask off here. Here we go. Virtual Labs, Fall 21. Lab 3 vapor pressure. There we go. And so right now I don't see the file, but that's because in Excel I've highlighted all Excel files, so I want to open all files. There it is, water JST. So I go to open it. And it's nice when you do an import wizard with Excel, it allows you to just see how the files would be formatted. So it's delimited, which means characters such as commas or tabs separate, and you can see that that is true. It looks like there's a period that's separating, so when you say next, you'll see how it analyzes how it breaks out the column. So it has a time mark in seconds, it has a temperature in K, and it has torr and pressure, and that's perfect. So then you just say next and finish, and it exported just like we would like it. Now the last thing I would do with this data if you have time. That run took us a little bit over 30 minutes, so it's maybe about 45 minutes, but I would go ahead with this data right now and quickly work it up and make sure that it makes sense. So it's temperature versus pressure. If you take if you take 1 over temperature versus the log of pressure, it should be a linear fit. And so that's kind of one of your checks that your data was good. The reason that may not work is because you actually have trailing data at the beginning or trailing data at the end you might want to cut out of there. My experience has been that you should graph time versus pressure. That will help you make decisions about what beginning data you should cut out and when the data starts to flatten at the end, and you can stop then. Then cut that beginning and end pieces out and then regraph the 1 over temperature versus the log of pressure, and you should then have a straight curve, and that will be confirmation that you have good data. I hope this video helps you know how to use this equipment.